Okay, hello. Today we're going to talk about indices and roots. This is part 1, and I'm teacher Mark. In part 1, the contents are: first we'll have the vocabulary about indices, then the basic rules of indices, and then we'll have some examples of the rules. So let's get started. Okay, so first let's go over some of the vocabulary about indices and roots. So if I start with, let's say, some number, which I'll call a being a real number, and I'll put it to a power, let's say this. So what do we call this arrangement? So first of all, the number on the bottom, a, it's called the base. And then the number up here and to the right, above and to the right, we have several words for it. We can call it an exponent, or some people call it a power. These are the most common ones, exponent or power. So we have a base on the bottom, and a number up and to the right is the exponent or power. Okay, so now let's talk about some of the rules for these. Okay, so the rules. Let's start out here, starting with a again, some number, and I'm going to put it to a power of 0. That's a 0. Okay, so some number to a power of 0, that is equal to 1. Small exception here. This is where a is not equal to 0 itself. Alright, so a number to a power of 0 is 1. The exception, if a is equal to 0, in other words, 0 to the power of 0, this is also 0. Alright, but for 99% of the cases, a number a to the power of 0 is 1. For example, 5 to the power of 0 would be 1, as well as something like negative 2 to the power of 0 would be 1, and even we can have fractions in there. Let's say 1/2 to the power of 0 would also be 1. Okay, so a to the power of 0, 1. Alright, let's go to the next one. So the next one we'll have a again, a to the power of 1. Okay, a to the power of 1 will just give us a back. So for example, 5 to the power of 1 is just 5, and negative 2 to the power of 1 is just negative 2, and of course 1/2 to the power of 1 is just 1/2. Alright. Realize also that the equal signs here, they go both directions. So in other words, if I have some number like 8, I can think of it, or I could write it as 8 to the power of 1 if that helps me with my math problem. Okay, let's go to the next one. Alright, next we're going to talk about a to the power of negative 1. I've done 0 and 1, so just to kind of fill it out, I'm going to do negative 1. So a to the power of negative 1, it would flip it to be 1 over a to the power of 1. So, in other words, what will this happen here? If I have 5 to the power of negative 1, that will become 1 over 5, or 1/5. Of course, there's a 1 there as well, but it's still just 1/5. Negative 2 to the power of negative 1 would become negative 1/2, which we could also write as 1 over negative 2, but that's also just putting the negative sign in the beginning. And if I had, let's say, 1/2 to the power of negative 1, that would become 2 over 1, so it flips the fraction upside down, which in this case would just be 2. If I had, let's say, 3/4 to the power of negative 1, that would become 4 over 3. Alright, so with -1 as the exponent, it basically flips the number upside down. If it's a whole number, like 5, it becomes 1 over 5. Negative numbers will still be negative, and fractions will just be flipped upside down, like 1/2 and 3/4. Okay, let's go to the next one. Now, the next one, I'll have some number a again, and to the power of n, and I'm going to multiply that by a to the power of m. So in other words, here you should notice I have the same base, the number on the bottom, the base, the same base in both of them, and I have different numbers, or it could be the same number on the top in the exponent position. So in this case, what happens? We get a to the power of n plus m. In other words, we add them together. Alright, so let's see here how that happens. So if I have 5 power 2 times 5 power 3, this becomes 5 to the power of 2 plus 3, which in this case is just 5 power 5. It could also be, let's say I had 3 to the power of 2 times 3 to the power of -1. Okay, and so in this case, I'll get 3 to the power of 2 plus -1, which would become 3 to the power of 1, or just 3. So even with a negative number in the exponent position, I can just add them together. Now we should also notice the exponents don't have to be different. In other words, n can equal m. So in other words, if I had, let's say, 7 to the power of 3 times 7 to the power of 3, that will just be 7 to 3 plus 3, or in other words, 7 to the power of 6. So let's take a moment. Let's see why this is. So let's say I had, alright, so let's say I had 9 to the power of 2 times 9 to the power of 3. So if we think about this, 9 to the power of 2, that really means 9 times 9. 2 means 2 9s multiplied together. And then if I had 9 to the power of 3, well, that would just be 3 9s multiplied together. And so if I'm multiplying these, alright, so look what I have here. I've got 1, 2, 3, 4, 5. So that's why I have 9 to the power of 5, because there's 5 9s multiplied together. So this is where the idea of n to the power of m, a to the power of n, times a to the power of m becomes just a to the power of n plus m. Alright, let's go on to the next rule. Okay, now the next one will have a to the power of n over a to the power of m. So in this case, we're dividing. Okay, so in this case, we get a to the power of n minus m. In other words, you subtract the two. Notice again, the base, a, is the same in top and bottom. So in other words, if I have 5 to the power of, let's say, 6 over 5 to the power of 2, that this just becomes 5 to the power of 6 minus 2, which becomes 5 to the power of 4. So let's see why this might be. So if I have, let's say, 7 power 3 over 7 power 2. Alright, so I could write this out a long way by on the top just putting 3 7s, because 7 power 3 means 3 7s multiplied together. And on the bottom, 7 power 2 means just 2 7s multiplied together. So I think you can see from here that I can cut the 7s. They're multiplied together. And so I'm left with just 1 7 on the top. 7 power 1, which is just 7. And this power 1 is coming from 3 minus 2. 3 minus 2. Okay, so that's how it's happening. Alright, now as a side note, this gives us a little bit of a way to think about how a to the power of 0 is 1. Okay, because let's take an example. Let's say we have 4 to the power of 2 over 4 to the power of 2. Well, we can see that if we wrote that out the long way, that would be 4 times 4 on top and 4 times 4 on the bottom. And so we can see here that the top and the bottom are the same. They cancel out and they give us 1. And so remember that 4 to the power of 2, 4 to the power of 2, that can be written as 4 to the power of 2 minus 2. The 2 from the top and the 2 from the bottom subtracted. Well, that's just 4 power 0. 2 minus 2 is 0. And that's 1. So the rule about dividing, where we subtract the exponents, is subtract the powers, that gives us a way to think about and remember that a number to the power of 0 is 1. Okay, so let's see another thing. Let's say I had a bracket and a to the power of n, close the bracket, and then m outside. Well, in this case, we get a to the power of n times m. In other words, if I have, let's say, 5 to the power of 2 inside brackets, and then a power of 3 out here, this becomes 5 to the power of 2 times 3, or 5 to the power of 6. Alright, so let's see why this might be. Well, 5 to the power of 2. So if I have 5 to the power of 2, and the 3 up here means I have 3 of those, all multiplied together. Well, following what we saw before with addition, because these are the same base here, I should add these together. So it's 5 to the power of 2 plus 2 plus 2, which gives me 5 to the power of 6. Alright, so instead of 2 plus 2 plus 2, we can just reduce that or simplify that as a multiplication, so 2 times 3. Okay, so now let's go on and make this a little bit more interesting. So if I have a and b inside, and then a power n out here, notice that a and b are multiplied, so this gives me a to the power of n, b to the power of n. Alright, and if I go a step further, let's say I have a to the power of m, and just b, and then n out here, that this will give me a to the power of m times n, b to the power of n. So in other words, the n multiplies by the exponents inside, and the b really has an exponent of 1, because we just didn't write it, so that default is 1. So let's see if I have an example of that. So if I have something like 2 power 2, and let's say 3 power 1, so just 3, and I put that to a power of, let's say, 3. Alright, so then this will give me 2 to the power of 2 times 3, and 3 to the power of 3, which it becomes 2 to the power of 6, 2 times 3, 6, and 3 to the power of 3. Now let's look at the case where if we had a over b. Now there's a fraction a over b to the power of n. Well, that is just equal to a to the power of n over b to the power of n. Right? So the fraction just has the exponent sent to or distributed to both places. So in other words, a fraction like 2/3 to the power of 3, that would become 2 to the power of 3 over 3 to the power of 3. In other words, 2 to the power of 3 is 8, 3 to the power of 3 is 27, so 8 over 27. Now let's look at something that's kind of important. We'll talk about a negative number. If we have a negative number, like let's say minus 1, for example, and I put to the power of n. Well, this will become basically positive 1 if n is even, and it will become negative 1 if n is an odd number. All right, so in other words, negative 1 power 4, because 4 is even, it'll give me 1. And negative 1 power 5 will give me negative 1 again, because 5 is an odd number. Okay, now it doesn't have to be negative 1. It could be anything, like, let's say negative 2. So negative 2 to the power of 2 would give me positive 4, right? It would basically be negative 2 times negative 2. And so you know negative times negative is positive, so we get 4, right? Positive 4. Now, an important thing to notice here, if we have something like negative 2 to the power of 2, all right, we saw just now that is positive 4. But negative 2 to the power of 2 is not equal to negative 2 power 2 without the brackets. In other words, over here on the left, it becomes negative 2 to the power of 2, giving us 4. But over here on the right, it's like negative 1 times 2 to the power of 2. Well, in this case, because the negative sign is outside, not inside brackets with the 2, so then we get basically negative 1, and 2 times 2 is 4. So in this case, it'll be negative 4. And clearly you can see 4 is not equal to negative 4. So it's very important when you have negative bases that you remember when you need to have brackets to show that the negative and the base value are grouped together and not separate like over here. Alright, so now let's take a look at this. So we saw if we have a times b to the power of n, that becomes a power n, b power n. And it's very important that we see that this is multiplying, that inside here it can be multiplying or dividing, we saw the fraction, for this rule to work. In other words, a plus b, so now I'm adding to the power of n, is not equal to a power n plus b power n. Okay, very important. This is not equal. And likewise, subtraction is not equal to a power n minus b power n. Okay, very important to remember. Inside must be multiplying or dividing to get this result. Okay, one more we're going to talk about today before we close. So we saw already how a to the power of negative 1 becomes 1 over a. Now let's talk about a more general case. So if I have a to the power of negative n, so for n greater than 0, so a to the power of negative n, this becomes 1 over a to the power of n. Okay, so in other words, if I have 5 to the power of negative 2, this becomes 1 over 5 power 2, which becomes 1 over 25. Alright, now this can also apply to a fraction. So if I have a fraction like, say, 2/3, and I bring this to a power of, let's say, negative 3, well, we can do this in steps. The first thing is we can deal with the negative, and the negative means that the fraction flips. So it becomes 3 over 2 to the power of 3. And then, knowing how this distributes, that means 3 power 3 over 2 power 3. So, in other words, 3 power 3 is 27. 2 power 3 is 8. So this is how it would work with a fraction. Okay, Well, that's it for the basic introduction. You've seen the vocabulary, that we have a as the base and n as the power or exponent. And you've seen the basic rules. So tune into the next one, the next video, where we'll see some more rules and we'll do some more practice with these. Okay, thank you for watching. Have a good day.